Hi, hello everyone. So I just want to go through a brief introduction on how to use this repository to basically create your own speech recognition system for embedded electronics or any kind of robotics project that you may have. Now, I'm going to keep this short because this is just not about setting up your development environment and everything. This is just how to build and use the project. I have included a link in the description with the GitHub repository for where you could clone and get all of the code and details on where to look for information on setting things up. So let's start firstly with cloning the repository. So we could do it straight from here, or you could do it through command line if you like. This is the link, so I'm just gonna, well, you're not seeing this here, so I'm just gonna store this in my Skainet repo folder. Right. So as you can see, it's gonna clone and it's gonna clone pretty fast. How I designed it is the code base is pretty, I wouldn't say very lightweight, but it's a lot smaller than it was. I did a lot of cleaning up into the repository to make it simple to use. And as you can see, if you check the official Skynet framework, there are a lot of examples and a lot of components that you may not need right now. So the whole purpose of this was to create a project, a very baseline project that's very simple to use and only necessary components and code. So the first thing that we did was clone repository. Now, once your environment, your ESP-IDF has been set up, I'm using the VS Code extension. So like if I go to extensions and I search for IDF, I have this ESP-IDF installed, right? And it will create an icon on the side here, IDF Explorer. So the first thing I want to do is open an IDF terminal. You could open a terminal manual if you want, but as you can see, what this does, it executes an export script based on the terminal that you're using. And that would basically set all your environment variables and any other parameters that you would need to use the tools within ESP-IDF. So the first thing that we want to do, we already have the project here. Notice that we have assets, which is just some pictures for now, and in future any new components. Here we have our component folder, which is local code. So two of these, I actually had to do some custom code to get these things operational. And these others were included with the framework. And here we just have our main code, which is the fetch and detect task for the speech recognition framework. So let's minimize that. All right, first thing we want to do is like that. Everything is executed through idf.py. That's how the ESP-IDF uses this Python script to basically execute all their commands. So the first thing we want to do is, well, actually the first thing before that is to make sure we have the correct target set and make sure it's on the correct COM port. As you can see, this is where my ESP32-S3 is connected. Setting up your target, I have details on that in documentation as well. So let's do a menu config. So this is gonna basically configure the first thing that I will do. If you watch here, it does a build a little bit, and it should download some managed components, as you can see here. And you notice it's grayed out because it's in a git ignore. The reason for that is I don't want this being pushed to GitHub because these files are very large. So when you're doing the menu config to start with, or even build on Flash, it will download these managed components, which are ESP speech recognition servo, that is one I'm actually using for servo control, and the DSP. So it will download all that from the Espressif registry, component registry. So the first thing we enter the menu config, which is configuring the SDK. You're gonna want to first set your serial flasher config. So depending on if you have a 8 meg or a 16 meg flash, you could leave this as 8 meg, but it will just throw an error, well not an error, sorry, a warning when you're building or executing that it detected 16 megs, but you have your SDK configured for 8 megs, so you can change that if you want. But this one that I'm using here is a 8 meg, the other chip that I have is a 16 meg. So we configure that. Everything else should be good to go. Unless you want additional features, you could come in here and configure them if you need. For the speech recognition, this is where it is. the model data is loaded onto the flash. Now we could have, if you have an SD card set up, you could do that as well, but using the PSRAM on the S3 is what it was intended for. It's very fast. Here we have some new features, which is basically noise suppression. I haven't tested these fully as yet. This new model here, voice activity detection, VADNet 1 was introduced as well. I have not tested that thoroughly as yet. This came with the ESP-SR 2.00, which came out around a little after the 14th of February 2025, I believe. And to use the system, you're going to basically want to use our wake words. So these wake words are basically similar to like Alexa or Google that you would use to activate the system. So right now it's configured to Jarvis. You could configure multiple if you want. So you could say any different commands and it will basically activate the system. So of course this is an IAM suit, so I have it as Jarvis. You have others here you can use that's predefined. Then you want to basically you ignore these little text. It's used here. It's apparently a Windows thing. So we want to basically configure our speech commands. And these are the three that's configured right now. This is wake up, hulk out, and let's go. So these are phonemes. It's basically how a word is actually pronounced. And that's what the system uses to identify these different commands. So to use this, let's exit the SDK config. We do not want to save. Right. Now, it downloaded some managed components when we went in there. We need some tools from the ESP-SR folder. So let's go into cd managed ESP, sorry, expressive ESP-SR/tool. Right. So if we check here, we have this Python script, multinet g2p.py. Now this is going to need a Python environment setup. It's going to need some additional libraries. If you try to run it, it will tell you what needs to install through pip, or however you have your Python setup. And the documentation for expressive Skynet and ESP-SR will also describe how to get all of this set up properly. Yeah, so let's execute Python energy period -t hello world. So what this is going to do is going to convert this phrase hello world. It's also not case sensitive. It's you could type this in all capitals. In fact, let's test that. Ignore the visual glitch. Windows for some reason doesn't like how this works. This ESP-IDF terminal. And so yeah, so as you can see, it's not case sensitive. Whatever case you can mix it up, it'll basically spit out the same phonemes. And you're gonna take this and put this into the SDK configuration through the menu config that we saw earlier. And that's how you add new phrases. And to configure those, I actually included some routines here during a detection task. So when it detects the wake word, it's gonna go through a switch case here. So these different cases will reflect the different IDs, the command IDs. Command ID 0, command ID 1, command ID, whatever, how many you want, up to about 200, I believe. Okay, so we have this here, and so we already configured everything. We already did many config, so we want to build the project. Right. Oops. All right, so this is something to take notes. You want to be in the project roots, right? Because that is where the CMake list is for the entire project. That's where you want to start building, because it'll take these CMake lists and then start building the components and whatever other. Each one has its own CMake list that it will continue to build. So when we're building, we want to start here. Alright, so it's going to take some time. It'll tell you if you build before, you don't even need to you do the menu config because it's already the SDK config here will always have predefined settings. But if you do the menu config, you could configure it how you want, or you could basically copy the defaults here into this file to use the defaults for this ESP32-S3. Alright, so it's finished building, so it tells you that it's okay to flash. If it wasn't good, there would be a lot of errors. So let's do a idf.py flash. Now you could do a flash monitor, but I prefer to always do just a flash. Because what I found was sometimes when you do a flash monitor, it enters a kind of weird state. It doesn't respond. So I do a flash, and then when you do a IDF by monitor, it will reset the SOC. So it goes through two stages. The first stage is where it will build, it will flash the program. Sorry, I'm being a little redundant. It will put the application data into flash, and then it loads the model data onto the PSRAM. So this will usually take a lot longer. It's usually a little slower. Now there are variants of the ESP32-S3 that comes with USB-C. This one I'm using here is original. It comes with micro USB. So the USB-C one may be a little faster, but again, it all depends on the speed of the flash as well, or the PSRAM. Right, so okay, so it's completed, built and flash. So now we could basically start talking to the system. So let's do idf.py monitor. This will open a sequence here that will, a monitor window that will wait for you to enter a command. So as you can see, it goes into a waiting state where it says detect start. It's gonna keep staying there until it detects the wake code. So let me lower my mic a bit and let's test it. Jarvis, wake up. Jarvis, let's go. Okay, so as you can see, it went into, it was in a waiting state, and as we said, the wake up command, it executed the open sequence, which was command ID 0, and as we said, let's go, it executed the close sequence, which was related to command ID 2. And that's basically how you are going to use this project to build your future designs or any custom code that you want to implement. To exit this monitor window as well, you press Ctrl, right brackets, and all that is included in the documentation. So thanks again for watching. If you like to support my channel and you enjoy the content that you're seeing here and the creative ideas, I have a lot more creative ideas to come. Working on different robotics projects. So if you like to support me, don't forget to just like, share, and subscribe. And I'm looking forward to working with you guys. Any issues that you may have, post them in the comments below, and I'll try to respond as quickly as I can. So thanks again, and cheers.